Simplifying monomials, or monomials. Well, let's say I had 5x squared y times 6x cubed y to the 8th. Remember, with your rules, when you multiply, you add exponents. The coefficients, you always do what it says. So 6 times 5, 30. Then there's 5 x's, 9 y's. Let's even say, let's make that a negative 4 x to the 4th y cubed, and maybe a 5x to the negative 7y. Let's throw a negative exponent in there. 4 times negative 4 times 5 negative 20. Same thing, add your x's, negative 3, add your y's. Now, if the directions just say simplify, technically you can leave it like that. Remember, though, if it says make all exponents positive, remember a negative exponent to make it positive. If it's in the numerator up top, you put it in the denominator. If it's in the denominator, you put it up top in the numerator. So that could also be negative 20 y to the 4th over x cubed. So remember, the negative exponent has nothing to do with a negative sign out front, just its position in it. You can also divide. Let's see. Something like this. Remember, the numbers out front, you treat them like normal. So 6 goes into 18.3. And then variables, when you divide, you subtract. So 4 minus 2. And then 9 minus 5. There you go. Same thing, you could also have negative exponents here and there. Kind of to make things interesting. But same principle. So reduce the numbers out front. 8 goes into both of those. So 3 over 2. And then still subtract. Negative 5 minus 9. Negative 14. 3 minus negative 2. 5. Sorry about that. It's early in the morning. And same thing, if you wanted to make all exponents positive, the y can stay, but the x, bring it down. Now, as far as exponents, excuse me, remember, let's say we have this. Remember, the numbers out front, we always do what it says. So 5 cubed, 5 times 5, 25 times 5, 125. And then exponents, you multiply. So that's 18 and 6. Now, just to show you really fast where this comes from and why you multiply it, if you were to expand it out and write it a total of 3 times, that's where your 125 comes in, 18 x's, 6 y's. What about anything to the 0 power? Anything in parentheses to the 0 power, 1. And let's say, last but not least, they give you something like and they have it double. They have you need to raise to a power and divide. In this case, what I personally would do, reduce the inside first. So 5 goes into both. So that's 2 over 3. 2 minus 4, x to the negative 2, or you can go ahead and put it down below. 3 minus understood 1, 2y's up top. So now 2 to the 4th, 16. Multiply to get 8. 3 to the 4th, 81, because 3 times 3 times 3 times 3. Also, x to the 8th. Well, hope this was of help to you. Have a great day. And oh, I forgot one thing. If they were to get a little weird on you, what about if I had a to the 3x times a to the 4x? Looks weird, but the same principle. If they have the same base, like in this case, a and a, you can just add the exponents. So a to the 7x. If you had something like x to the 2n over x to the even n plus 2, something like that. That would just be, remember when dividing you subtract, so 2n minus n, but remember to distribute, minus 2, so that would just be x to the n minus 2. Let's even say I had x cubed to the n minus 8. Distribute the 3, so that's x to the 3n minus 24. One more, let's a to the 5x over b to the 4y. And let's say I want to raise it to the 2x power. Well, literally, you just multiply. So a to the 10x squared over b to the 8xy. I know it looks weird, but that's the stuff sometimes you see on the ACT. Just doing the same operations, but instead of numbers, they throw variables in there, so you can't do it on a calculator. Now that's all. Hope you have a great day.